This is the AB 91 to 94 review. Calculators are not allowed, and this is number 3. And all 3 of these deal with coasting problems, which is we have objects that will stop pushing and just coast to the end, and the goal is to figure out how far the object is going to travel before coming to a complete stop. So before we get going on these, we want to recall the formula that relates the velocity to time. So the velocity at any time will be the velocity we start with times e to the negative k over m times t, where k is a constant that depends upon the object and the surface that it's coasting on. M is the mass of the object, and v initial is the initial velocity of the object, whatever it is, when they stop pushing. So based on this, we, if you recall in our notes, did the antiderivative in order to find the position function, and then we plugged in the fact that we have coasted nowhere when time is 0, and then when we did that, we were able to get a position function whose limit as time went to infinity we could take. And when we did that, we ended up with a coasting distance. You can go back and look at your notes for this. A coasting distance that was v initial times the mass divided by the k. So that means if in all of these problems we can identify the v initial and the m and the k, or if we know that ratio of k over m, then we can compute the coasting distance. So here in part A, we're given the mass, and we're also given this velocity function. So that means we were told v initial is 7, and we were given the ratio of k over m, which was 0.002. Now in order to compute the coasting distance, I don't want k over m, I want m over k. So that means this number, we need to take the reciprocal of it. So for this one, my coasting distance will be my v initial, which is 7, and then I'm going to multiply by the reciprocal of this 2/1000ths. So if I multiply this out, I get 7,000 divided by 2 is 3,500 meters. By the same token, if we look at part B, we've got the same thing. I've got the v initial is given to me as 5, and my k over m is 5 over 110, so the m over k would be the reciprocal of that, and I can get the coasting distance is 5 times 110 over 5. 5's cancel, I get 110 meters. Now the last one's a little different, and the reason it's different is because I did not give you the velocity function. Instead, we're going to use that coasting distance is v initial times the mass over the k, because I tell you the k, I tell you the v initial, and I give you the total mass of 70, which is coasting to a stop. So in this case, we'll have 8 times 70 over that 5.6, so 560 divided by 5.6, we get 100 meters.